Hey guys, in this video I'll teach you about slope fields. Slope fields are basically uh, a field of slopes. I know it sounds funny, but basically a XY plane that has the slopes that will draw out a function. So here's what I mean by drawing out a function. So imagine we have y equals x squared. Well, we know that if we took the derivative of that, it would be 2x. If we took the integral, it would be actually it would actually be y equals x squared plus c. We talked about particular solution versus general solution. General solution means plus c. Particular solution means that it can go through any one of these. That means the c is going to stay as a constant. Okay, so the derivative of y equals x squared is 2x. Okay, so at 0, what is the slope? So now I'm looking here. At 0, what's the slope? Well, 2 times 0 is 0. So you go to any one of these, and it's 0, 0, 0. At 1, you just plug this in, you get 2 times 1, it's 2. So you're going to have to go to x equals 1. Let's just pretend that is here. And we're going to say, okay, if x is equal to 1, my slope is 2, 2, 2, and so on. So now let's say when x equals negative 1. So when x equals negative 1, my slope is negative 2. So you go to negative 1 and you make a slope of negative 2. And what happens here is you basically continue making all these slopes. Okay, so what is the slope at, negative 3, positive 3, negative 2, positive 2. And what you end up coming up with is the picture of the original function. So some of you might say, well, if I have the function, why would I draw a slope field? Well, when you guys were solving differential equations, there are times that you may receive something that looks like this as your dy dx. You can't integrate this. So what would happen here is if you basically put in some xy points, like let's say 1 comma 1, you'll end up figuring out the slope for this picture, and those slopes will form the original function. So 1 comma 1 will give me 2. So if I go to 1 1, that looks like this. What about this point here? This point here is 1 comma 2. So when you put 1 2 into this, what is my slope? 1 plus 2 makes 3, so my slope is 3. When you go here, this point here is 1 comma 3. So when you put 1 3 into this, you get 4. So then you just do that. So what the AP does typically is they give you 9 points and you just literally have to draw these lines. So let's say we wanted this point right here. This point here is negative 1 comma 1. Well, when you put negative 1 plus 1 into this, you're going to get a 0 slope. Great. So you just draw a horizontal line. When you go to negative 1, 2, you get negative 1 plus 2. That's 1. So there's a 1 slope. And you just sort of estimate it. And so the last one here would be negative 1, 3. So that's 2. So this one should match this one here. And you should try to make them match. In this case here, you get 0, 1. So that's just 1. So it should match your 1, which was here. In this case here, you get 0, 2. That should match 2. And then this case here, 0, 3 should match the 3. You'll notice that this one, and this one, they all look the same. It's literally so easy. They'll give you the 9 points, and they will ask you to draw a slope field. You just plug those 9 points into your differential equation, and all you have to do is come up with the slope and just estimate. So the most important thing about slope fields is to observe where you can see zeros, undefined, positives, negative slopes. So if I gave you dy dx, if you go to x equals 0, which is here, it'll be vertical everywhere. When x equals 0, it'll be vertical lines. Okay? What else do we notice? We notice that when y and x have the same sign, it'll be positive. So this quadrant, x and y have the same sign, and this quadrant, x and y have the same sign. So all my slopes, regardless how steep they are, will all look like this. All positive slopes. And when x and y are opposite signs, all my slopes will be negatives. I don't know how steep they're going to be, but that's pretty much it. What about this? Well, x minus y, try to figure out where it's going to be 0. So just set this equal to 0. Everywhere x and y are the same value, like 1, 1, 0. Like 2, sorry, not 1. Yes, 2, 2, 0. 3, 3, 0. Negative 1, 0. And that's because if you put, let's say, this number here, which is 1, 1, 1 minus 1 makes 0. So you kind of have to look for those in the picture. Remember that the slope field is always your original graph. Sometimes the AP gives you the dy dx, or sometimes they say a multiple choice question that says, choose which one represents the graph, and they give you the actual graph, so you would have to take the derivative to see which one it is. But basically, it draws out the original picture. All slope fields draw out the original picture. So if the AP gives you dy dx to be 2x, you're going to be looking for a parabola. Now, you just have to take a look at the picture to see which ones give you the parabola, or you could try to look for what gives you 0, undefined, positive, or negative. So if you have something where everybody across is all positives, then you might have something that looks like, I don't know, I'm just going to make this up, but like x squared plus y squared. Why? Because everything, all slopes, when you're done, are all positives. You might have something that looks like negative x squared plus y squared. I'm not too sure. That will give you all negatives. You might have something that has some positives in quadrant 1 and 3, and then negatives in the other. So basically, all you have to remember for slope fields is if you're basically going to get 9 points. The AP will give you one here, 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 maybe, another one here, 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 and you guys will get a worksheet on this. But all you have to do is say, okay, this is 2x plus y equals dy dx. What point is this? This is the point 2, 1. Okay, I'm going to put 2, 1 in here. It's going to be 5. I'm going to make it steep. That's all. You literally just plug in the point. This is 2, 2, so that's going to be 4, 6. I'm going to make it even more steep, and so on. And constantly look for the zeros. Remember, the final thing is that your slope field draws out, the picture of the slope field is your original function. So be careful with the multiple choice because it's the picture of the original function. So I hope that was quick and helpful. You could also find other slope field videos on YouTube to watch. Have a great one.